Welcome back to this next video in which we are discussing HPVs and cervical cancer. Okay, so we're now going to introduce the HPVs, the bad guys of this great story. So the first thing that I want to do is write down what does HPV actually stand for in full, and it stands for Human Papillomavirus. So H is for human, and then P is for papilloma, and then V is for virus, and papilloma and virus is joined together. And of course, there is not just one human papillomavirus, there are multiple different types of human papillomavirus, and it is important to distinguish between the different types. Even though they're very similar, they have very similar life cycles, there are differences in between them, so we do need to understand that there are multiple different types of human papillomaviruses. So it's not just a single virus. There are multiple different types that do have important, significant differences in between them. Okay, so that's what HPV stands for, human papillomaviruses. So the next thing that I want to tell you is how many different types then of human papillomaviruses are there? Well, I'm not going to give you the exact figure because the exact figure changes year on year. Okay, we're discovering more and more different types of human papillomaviruses, so the figure for how many different types there are is continuously changing. At the moment, what we know is that there are greater than 120 different types of human papillomaviruses. So at present, in 2016, we have found greater than 120 different types of human papillomaviruses. And let me just talk about how we name these different types of human papillomaviruses. So it's done very simply. You take HPV and then you stick a number after it. So for instance, there is human papillomavirus type 1, and it would be written just like so, HPV, then with a 1 after it. So this is a certain type of human papillomavirus. So this is the way that we name the different types of human papillomavirus, just HPV with a number, and that number is the type of human papillomavirus that you're talking about here. Okay, so there's greater than 120 different types of human papillomaviruses, and the great thing that makes them all similar to one another is they all infect stratified squamous epithelia. Okay, so this type of virus, and we'll go over the structure of the virus later on. At the moment, I'm just doing the basic introduction. All of the more than 120 different types of human papillomavirus, they all infect squamous stratified epithelia, and that's all they infect. They don't go deeper into the body than that squamous stratified epithelium. However, the first major division that we can make of the human papillomaviruses is we can divide them into the human papillomaviruses which affect the keratinized squamous stratified epithelia, which is the skin, the epidermis specifically of the skin, and those which infect the non-keratinized squamous stratified epithelia, of which the cervix is an example. So that's the first division that we can make of these human papillomaviruses. So there are 120 different types. They all infect squamous stratified epithelia, but some of them infect keratinized squamous stratified epithelia, and others infect the non-keratinized squamous stratified epithelia. So each of the different types of human papillomavirus has a certain type of squamous stratified epithelium that it prefers to infect, and it will not really infect the other type. So it either likes the keratinized squamous stratified epithelium or it likes the non-keratinized squamous stratified epithelium. So at this point I would just like to remind you of the difference between keratinized and non-keratinized squamous stratified epithelium. So there is one major example of keratinized squamous stratified epithelium in the human body, and that is the epidermis of the skin, whereas there are lots of different examples of the non-keratinized squamous stratified epithelia, and of course the one that we've seen so far is the cervix. However, the picture that I drew in previous videos for the squamous stratified epithelium of the cervix we can use that for our picture of the squamous stratified epithelium in other places, even for the for the keratinized ones as well. So I'd just like to remind you of that structure of the squamous stratified epithelium that I drew previously. So let's just do this quickly. So at the bottom here is the basement membrane. Then sitting on the basement membrane, whoops, I'll go back to the thin pen, undo that. Then sitting on the basement membrane, you'll have the basal cell layer, and remember, this cell layer is the layer that gives rise to all of the cell layers above it. It's where the stem cells are that are dividing, and when they divide, they give rise to two daughter cells, one of which will remain attached to the basement membrane. It will remain in the basal layer, and it will become the new stem cell, and the other one which will move up into the more superior layers. So this is the basal cell layer here in white, and then on top of that we have the mid-zone. So I'll remind you of what I said earlier. There are loads of really complicated classifications for the different layers of squamous stratified epithelium. We can make this really, really simple by just dividing it into 3 layers, and for our purposes that will do. So you then have the mid-zone, which consists of the daughter cells from the basal cell layer division that have moved upwards and begun the differentiation process. So these are bigger than the basal cells, and they're not as cuboidal, they're more blobby. So here, and just to make the picture simple, I've only drawn about 3 layers there, but there would in fact be more layers of cells making up the mid-zone here. So I'll just finish this off. So here we are. This is the mid-zone here in blue, and then on top of the mid-zone, I'll have it in a pale green colour. You then have the superficial zone, which will consist of the flat cells, the squamous cells. So here they are. Again, I've drawn 3 layers of them, but in reality you'd have more than that. So this is the superficial zone. So let me remind you of the physiology of squamous stratified epithelia. On the basal cell layer, we've discussed that those cells will be dividing and giving rise to one daughter cell that's going to move upwards. As the daughter cell moves upwards, it goes through this differentiation process. It firstly becomes one of these cell types in the mid-zone layer, and then as it gets up into the superficial layer, it becomes flatter and flatter. And remember, if we're talking about a non-keratinized squamous stratified epithelium, the cells in the superficial layer will all still have their nuclei, and they will not become absolutely overloaded with the cytoskeletal protein keratin. Whereas if we're talking about the epidermis, again, this picture is still valid, but we'd want to take the nuclei away from the most superficial cells of the superficial zone, because as they move right up to the top, they lose their nuclei and they become overloaded with keratin. So that's just a reminder of the difference between keratinized and non-keratinized squamous stratified epithelia. The cells in the most superficial layer are completely overloaded with keratin and don't have nuclei in the keratinized squamous stratified epithelia, whereas they're not completely overloaded with keratin, and they do still have nuclei if we're talking about a non-keratinized squamous stratified epithelium. But overall, very, very similar structures. Okay. So, I'd now like to give you some more examples of non-keratinized squamous stratified epithelia, and there's another term that people often use for non-keratinized squamous stratified epithelia, and that term is to call them mucosal squamous stratified epithelia. We can also call keratinized squamous stratified epithelia cutaneous squamous stratified epithelia, which of course just means pertaining to the skin. Okay, so more examples of non-keratinized or mucosal squamous stratified epithelia, where these mucosal types of HPV, human papillomavirus, can infect along with the cervix. The lining of the vagina is also a mucosal squamous stratified epithelium, so I'll add that one in straight away. In addition, the lining of a portion of the female external genitalia, the vulva mucosa, is a mucosal squamous stratified epithelium. So the vulva mucosa is also a squamous stratified epithelium. So when you're looking at the female external genitalia, I'll just draw a little picture of this, and of course I risk at the moment making the video being taken off YouTube by doing this, but I'll draw a basic picture of this. So you have the labia majora and this is probably going to be an awful picture. This is supposed to represent the labia majora, and then inside of that you'll have the labia minora, which are here, and then of course you'll have the urethral opening and then the vaginal opening here, and all of this surface here is known as the vestibule, and that will be coated by a mucosal squamous stratified epithelium. Also, the lining of the labia minora is a mucosal squamous stratified epithelium. The lining over the labia majora here is skin, so that's a keratinized squamous stratified epithelium. So let me just put a few little annotations on this. So these are the labia minora, so this bit here and this bit here, and they are coated by the vulvar mucosa. And these bits here, and I'm going to have to change colour soon, I'm getting bored of red. These are the labia majora, and they are coated by skin, so they are not a mucosal squamous stratified epithelium. And then in between the labia minora is then the vestibule, which is this portion where the urethral opening and the vaginal opening is. So this is the vestibule, and this is also coated by a mucosal squamous stratified epithelium. So basically, on the female external genitalia for a little while, you also have mucosal squamous stratified epithelium, is the message from that picture. Do not take this as the perfect picture of the anatomy of the female external genitalia. Okay, so also coming now to the male external genitalia, there is mucosal squamous stratified epithelium there. We'll do this now in green just to change colour. So the lining inside of the foreskin on the male external genitalia is also a mucosal squamous stratified epithelium. The fancy name for that is the preputial mucosa. So prepuce is the fancy name for the foreskin. And by the way, I should say that vulva is the fancy name for the female external genitalia. So we're using fancy medical terminology here. So drawing now a little picture of the preputial mucosa, if we draw the male penis, so here is the shaft, and then here is the glans with the urethra at the top, then we can have the foreskin sort of coming like this, and all of this lining of the glans of the penis, and also this portion underneath the foreskin, so on the outside of the foreskin. This, of course, can move over the top of the glans. On the outer portion of the foreskin, you'll have skin, and then as you come towards where it is joined on to the end of the shaft of the penis, that will become no longer skin, that becomes a mucosal squamous stratified epithelium, and that's called the preputial mucosa. Okay, that is not a great picture. Even worse than this, probably. Okay, so vulvar mucosa and preputial mucosa of the male and female external genitalia, those are examples of mucosal squamous stratified epithelium. Also, the urethral lining is an example of squamous stratified epithelium. So the lining of the urethra in both the male and the female. So the urethra, remember, is the tube that connects the bladder to the external world. So here it is in the female and here it is in the male. And the inside of that is lined by a mucosal squamous stratified epithelium called the urethral lining. So there's another example. Also, the lining of the anus in both the male and female is an example of a mucosal squamous stratified epithelium. So the anus is another one to add on here. And then finally, the lining of the oral cavity and the oropharynx is also an example of a mucosal squamous stratified epithelium. So the oral cavity and the continuation of this, the oropharynx, so the portion behind the oral cavity that connects up to the nasopharynx, that is lined by a mucosal squamous stratified epithelium. So we have a lot of areas then now that are mucosal squamous stratified epithelium, and it is not just the cervix that can be infected by these mucosal human papillomaviruses. Mucosal human papillomaviruses can infect all of these different areas. The cervix is particularly vulnerable to HPV infection for reasons that we will come on to later because of the metaplasia that is occurring. And you'll understand why once we've seen the life cycle, once we've seen how human papillomavirus actually infects the epithelium, you'll understand why the cervix is so vulnerable. Okay, so the next thing I want to do is give you examples of human papillomavirus types that come under these two categories. I've said that all human papillomaviruses can be can be put into one of these two categories. It's either going to be a cutaneous human papillomavirus or it's going to be a mucosal human papillomavirus. If it's a cutaneous human papillomavirus, it infects the epidermis, the keratinized squamous stratified epithelium. If it's a mucosal human papillomavirus, it affects these mucosal squamous stratified epithelia, which we have now listed and drawn in some cases here. Okay, so let me give you examples of each of these types. So starting with cutaneous. So cutaneous is nice and easy. Examples are 1, 2, 3, and 4. They are some notable examples of cutaneous human papillomaviruses. So they're nice and easy to remember. I'm not going to go through all 120 different types and tell you whether they're cutaneous or mucosal. I'm just going to give you some basic examples of each of these. So HPV 1, HPV 2, HPV 3, and HPV 4, they're all cutaneous squamous stratified epithelium human papillomaviruses. They infect the epidermis. Mucosal types are the ones that obviously we're more interested in because we are discussing their involvement in cervical cancer, and the cutaneous types are not involved in cervical cancer. So some important examples of mucosal ones are 6, 11, 16, 18, and then if you want some more, 31, 33, and 45. So once you've read up enough about human papillomaviruses, you just remember these automatically. But if this is the first time you're seeing this, you might think, well, why on earth would I want to remember this useless series of numbers? But as we go through, I hope you'll gain some familiarity with these different numbers of the HPVs and you won't struggle to remember it. If you're just going to learn 4, the important ones to remember are 6, 11, 16, and 18, because those are the ones that we now vaccinate against. Particularly 16 and 18 are going to become really important. Those are the ones that are most linked to cervical cancer, particularly 16. 16 is the lead bad guy in this. It's the ringleader. It's the worst one. Okay, right, so where are we now then? We have given some examples of cutaneous and mucosal human papillomaviruses. Okay, so these things infect their respective squamous stratified epithelia, and sometimes, but not always, infection of a portion of squamous stratified epithelium with a human papillomavirus can cause a wart. These are the causes of warts. However, what you need to be aware of is that it's not all the time that when you get infected with a human papillomavirus, you're necessarily going to develop a wart. There's a bit of a probability thing here. You can get an infection in the skin with one of these cutaneous human papillomaviruses, and sometimes it might lead to a wart forming. Sometimes it might lead to a infection that you can't actually see. It's there, but it doesn't actually cause a visible bulge in the skin, which we would call a wart. Okay, so I'm just going to put this here. Oops, where's the pen? So let's find some interesting colour to do this in yellow, I think. Okay, so we now want to talk about warts. So human papillomaviruses are the cause of warts on both the skin and also the mucosal squamous stratified epithelia. But, as I've said, you can get a human papillomavirus infection in either the cutaneous or the mucosal squamous stratified epithelium that does not lead to the formation of a wart. So there's a bit of bad luck in getting a human papillomavirus and then actually getting a wart. It's not 100% that if you get infected with a certain human papillomavirus that you will develop a wart. Okay, so warts, you can have them on either the cutaneous squamous stratified epithelium caused by a cutaneous HPV, in which case we call them papillomas, hence the name of these viruses. So a papilloma is a fancy name for a wart on the skin. This is a skin wart, a cutaneous wart, and this is obviously the reason that human papillomaviruses were initially called papillomaviruses, because they're the causes of papillomas. So a papilloma is a cutaneous or a skin wart, the common wart. So of course you can get cutaneous warts all over the body in principle. Anywhere where you've got skin, in principle, you can get a cutaneous wart, but there are certain regions that are particularly susceptible, namely the hands, and here we would call them palmar warts, and also the soles of the feet, and there we would call them plantar warts. So plantar means pertaining to the soles of the feet, and palmar means referring to the hands. So there's another name, of course, for plantar warts, and they're called verrucas. So verruca is a plantar wart. Okay, so as I say, it isn't assured, though, that if you get a human papillomavirus on a certain patch of skin that you will get a wart there. So it's a bit of bad luck that you get the human papillomavirus infection there, and you also get actually so bad that you get a visible disturbance. So other places that you can get warts, so that's what the cutaneous human papillomaviruses can do. Unfortunately, the mucosal human papillomaviruses can also cause warts on the areas where they infect. So they can cause warts on the cervix, they can cause warts on the vagina, they can cause warts on the vulvar mucosa, they can cause warts on the preputial mucosa, they can cause warts in the urethral lining, they can cause warts on the anus, and they can also cause warts in the oral cavity and the oropharynx. Now, there is a special name for the warts that form on these mucosal surfaces. Specifically, you would use this mainly for the mucosal surfaces in the genital regions rather than in the oral cavity. So the terminology that people use is condyloma rather than papilloma. So this means a wart in the genital region. So this is the fancy name for a genital wart. So I don't know whether there is a fancy name for the warts in the oral cavity and the oropharynx, but I don't think you'd refer to them as a condyloma. When you get a wart on the cervix or the vagina or the vulvar mucosa or the preputial mucosa or the urethral lining or the anus, that is all counted as the genital region, so that would be called a condyloma. Okay, and those are caused if you're unlucky enough to get a mucosal HPV infection and you're unlucky enough that it actually causes a visible disturbance, which is a wart. But again, I'll stress that you can have a HPV infection and not actually have a visible wart. It can just look like a normal patch of mucosa. Okay, right. So that's warts discussed. Let's now talk about the fact that mucosal human papillomaviruses can be split into the high-risk human papillomaviruses and the low-risk human papillomaviruses. We want to now talk about how these things can give you susceptibility to cancer, because at the moment all we've talked about is the fact that these can infect epithelium, squamous stratified epithelium. It can lead to warts forming there. Now let's talk about how it can lead to the formation of cancer. Well, not how it can lead yet, but the fact that it can lead to cancer. So this is particularly at the moment documented for the mucosal HPVs. However, there is a massive interest at the moment about how the cutaneous HPVs might be able to cause this as well, but I'll come on to that in just a moment. So let's just get a little bit more space here. So mucosal HPVs. We can now divide mucosal HPVs into two groups, and indeed people do divide them into two groups. The HR HPVs, which stands for high risk HPVs. These are the ones that if you get infected by them, you are at risk of getting cancer in that area. And then the LR HPVs, which are the low-risk HPVs. So I'll stress that this is a division that we make for the mucosal HPVs. So we're now just talking about mucosal HPVs, not the cutaneous HPVs. So if you get infected with a mucosal HPV, for instance, on the cervix, which ones can actually lead to the formation of cancer and which ones would not lead to the formation of cancer? The low-risk mucosal HPVs would not lead to the formation of cancer, whereas the high-risk HPVs would lead to the formation of cancer. So which of the ones that I've given you as examples are low-risk and which ones are high-risk? Well, low-risk mucosal HPVs include 6 and 11. Those are the two examples that I've given you up here of low-risk mucosal HPVs. And if you get a genital wart, if you're unlucky enough to get a genital wart, and a huge majority of the population will get a genital wart at some point in their life, the chances is that it will be HPV 6 or 11 that is causing that, and that does not mean that you are going to be at risk of developing cancer, because these two do not give rise to cancer. Then there are the high-risk HPVs, and the most famous ones, the ones that if you have to learn two, these are the ones to learn, are 16 and 18. You must learn their names. HPV 16 is massive. HPV 18 is the second in command. It's the second worst after HPV 16. Then, if you really want to be fancy, you can learn the other three that I've put up there, which are 31, 33 and 45, which we also acknowledge are high-risk HPVs, but they're much less likely to be the cause of your squamous cell carcinoma of the cervix. This one, I think, is believed to cause 60% of the cases of squamous cell carcinoma. So this one is the massive one that you must know the name of. I think this one is then another 10% of the cases, and then other high-risk HPVs make up the final 30% of cases. So these two are the two to learn above all others. Okay, so mucosal HPVs then, they can be split into the low-risk LR HPVs and the high-risk HPVs. Infection of a mucosal epithelium with a high-risk HPV puts that mucosal epithelium at high risk of becoming cancerous, at high risk of beginning the neoplasia process. And it is not just in the cervix that this can happen. The cervix is the example we're particularly interested in. The cervix is particularly at risk of HPV infection, and it's particularly famous that HPV infection can cause cervical cancer, and the story is very well understood and very well documented. And we think squamous cell carcinoma, you know, it's necessary to have an HPV infection, almost necessary to actually be able to get that form of cancer. However, if you get a high-risk HPV infection of the vagina, that also puts you at risk of getting vaginal cancer. The vulval mucosa, that puts you at risk of getting vulval mucosa cancer. The preputial mucosa, that puts you at high risk of getting preputial mucosa cancer. The urethral lining, again, the anus, anal cancer, you have a higher risk of getting that if you've had a high-risk HPV infection there. And even in the oral cavity, there is research showing that head and neck cancers are more common after having a high-risk HPV infection there. However, with these other cases, it's much less well understood. There is a lot of current research into expanding what we know about cervical cancer into these areas, but cervical cancer is the archetypal example. Obviously, I'm talking about squamous cell carcinoma of the cervix when I say cervical cancer. I've said that in the previous video that we are just talking about squamous cell carcinoma now. It's the archetypal example because we really do think that you cannot get this form of cancer without having a high-risk HPV infection on that squamous stratified epithelium. But do be aware that these other mucosae are at risk just the same. Whereas if they're infected by a low-risk HPV infection, that will maybe cause a condyloma, but it's not going to put you at risk of getting cancer at that place. Now, let me just discuss the cutaneous HPVs. I've just said that the high-risk mucosal HPVs can cause cancer in the other areas, and we are beginning to acknowledge that, not just squamous cell carcinoma of the cervix. It's also, we think, going to turn out that we should be splitting the cutaneous HPVs into a high-risk and a low-risk group, and that some of these cutaneous HPV infections, the high-risk ones, might actually be the starting trigger for some forms of skin cancer. So we're starting to research the fact that cutaneous HPVs might be associated with skin cancer as well. However, I'm now going to say no more about these other forms of cancer in these other areas. We will be concentrating on HPV, high-risk mucosal HPV infection of the squamous stratified epithelium of the ectocervix, leading to squamous cell carcinoma of the cervix. This archetypal, very, very famous, very beautifully understood, very well researched mechanism. Okay, or example. Right, so the final thing that I want to do in this video now is actually tell you about the structure of the virus. So coming back up here, let's now talk about the structure of all human papillomaviruses. So, Human papillomaviruses, they are all non-enveloped, so I'll just put that here. They do not have an envelope. They do not have a membrane around them. They're very, very beautiful, very beautifully ordered viruses. They're not scraggly viruses with an envelope of phospholipid bilayer around them. They're not like HIV, which has an envelope around it. They are very beautiful. Okay, and they have, their outer surface is a capsid then. So remember, back to basic structures of viruses, the outer portion of a virus is either the envelope, but then underneath that you will have the capsid. If you don't have an envelope, then you just have the capsid. So the human papillomaviruses, they'll have the capsid, which I'll now draw here in white, and let me discuss the structure of this capsid. So this capsid is going to be a sphere. It's going to be the surface of a sphere, and inside that you'll have the genome of the human papillomavirus. And this capsid is constructed out of proteins. And the functional unit that you build the capsid out of is called a capsomere. So let me now just discuss what a capsomere is. So a capsomere is a pentamer of 5 proteins called L1 proteins. I'll draw a little capsomere here. So this is one viewed from the outside, and now let's split it into 5. So 1, 2, 3, 4, 5. So there are 5 proteins here, and all of these are a protein called L1. This is a protein that the virus has a gene for, and we'll come on to this in a moment. Okay, so to build a capsomere then, you take 5 of these L1 proteins and you bind them together to make a little capsomere here, and then to build the capsid, you put together loads of these capsomeres, like so, to make the surface of a sphere. And just to draw another picture of this capsomere from another angle, it would just look like this if we were to look at it from the side. So it's a little structure like this, made up of 5 separate L1 proteins, 1, 2, 3, 4, 5, like so. And then we put loads of these together to make the surface of this sphere, which is the capsid, like so. So the next question is, how many capsomeres do you have to put together to make the capsid? And we have an exact answer to that. The answer is 72. So you can now work out how many L1 proteins you use to build the entire capsid. Just take 72 and times it by 5. Of course, 72 times 10 is 720. Divide that by 2, and you'll get how much 72 times 5 is. So that's 360. So overall, 360 of the viral L1 proteins go into making the capsid. So there's my basic picture of the capsid. From now on, I'll just draw the capsid like so. So we'll imagine we've taken a cross-section through the virus and we're just seeing a little bit of the capsid around here. Now I want to show you what's inside the capsid, and this is why it's absolutely beautiful. Human papillomaviruses are so simple. You have the capsid, and then all you have inside them is the DNA. And the DNA is a little loop of double-stranded DNA. So this is double-stranded DNA, dsDNA here, that's in a circular arrangement. So this is circular double-stranded DNA, and it's really short. Guess how many bases this is? Rather than the 3 billion that you have in the human genome, this has 8,000 or thereabout bases. Of course, it's not exactly 8,000, but 8,000 pairs of organic bases. So it's a very, very nice small genome. This thing is actually understandable. It's actually comprehensible. It's actually, within computer's ability to completely understand this thing because it's so simple, rather than having 3 billion bases like the human genome. Okay, so a little circular piece of double-stranded DNA with 8,000 bases, and overall this codes for 8 genes, and this is in all the different types of human papillomaviruses. So everything I'm saying here about the structure of the virus, this goes for all the different types of human papillomaviruses, both the cutaneous and the mucosal ones. All of them have a capsid built out of 72 capsomeres, which are all made out of their L1 protein. So all of them have an L1 protein. All of them within the capsid have a circular piece of double-stranded DNA that is 8,000 bases long and which has 8 genes overall. So the final piece of information I'm going to give you in this video is the names of those 8 genes of the human papillomavirus genome. So, we split them into 2 categories: the early genes, which are expressed early on in the viral life cycle, so the early genes, and these have really simple names. They're just E followed by a number. So there is E1, there is E2, there is E4, so there's no E3, then there's E5, E6, and E7, and I don't know the story for why there is no E3, I'm afraid, but there is no E3. So there's 6 early proteins, we miss out E3, so we go up to E7. Okay, so those are the early genes, and we use the same names for the proteins for which they code, the early proteins. And then there are also 2 more genes, which are the late genes that are expressed later on in the viral life cycle, and we'll see this when we look at the life cycle, which are L1 and L2, and we've already come across L1, which is the protein that is used to make the capsomeres. And I've realised now it was very good that I actually told you the names of all these proteins, because I have forgotten to tell you about the role of L2 in the capsid. So, L1, the protein that this codes for, which is also called L1, is known as the major capsid protein, whereas L2, the L2 protein is known as the minor capsid protein. So it's okay that I forgot the role of L2 in the capsid, but I'm now going to tell you it. So L2, it's believed around 12 L2 proteins in the capsid, and they bind onto the capsomeres, some of them. So they can bind like this on the surface of the capsomere. So this is meant to be an L2 protein on the L1 pentamer. So some of the capsomeres in the capsid will have L2 proteins in. So it'll be 1 in 6, because you've got 72 capsomeres, only 12 L2 proteins, so 1 in 6 of them will get an L2 bound to it. So most of the capsomeres, 5 out of 6 of them, don't have an L2 bound to them, but some of them, 1 in 6 of them, do have an L2 bound to them. And it's not particularly well understood what the role of the L2 protein is. So to summarise then the structure of human papillomaviruses, they all have the same structure. They are non-enveloped, they do not have a phospholipid bilayer around their capsid, they are not scraggly, ugly viruses like HIV. Instead, they just have the capsid, which is made up of 72 capsomeres, which are all pentamers of L1, some of which have the minor capsid protein L2 bound to them. 1 in 6 of the capsomeres will have an L2 protein bound to them. You put all of those together to make the surface of a sphere, and then inside that surface of the sphere you put the genome, which is a circular piece of double-stranded DNA, 8,000 bases long, which codes for 8 genes, the 6 early genes here, which we haven't seen the function of yet, and some of them indeed we won't see the function of. E4 and E5, we don't understand the function of those very well at all, but we will see the function of E1, E2, and E6 and E7 in the life cycle later on. And then the late genes, which are the ones that code for these proteins that are components of the capsid, L1, the major capsid protein, and L2, the minor capsid protein. Okay, so that is the structure of all human papillomaviruses. So we will have a break here. In the next video, what we will move on to is the life cycle of human papillomaviruses, and this is where it really starts to get juicy.